Okay. So we're going to start with what you got for your rational roots. So we'll start with question 1. So can somebody tell me what your possible rational roots that you got are? Can I call that 8? Thanks. What else?
I have a question.
Oh.
So when you say possible rational roots, do you mean like the answer, so like plus or minus?
Mm-hmm.
Okay.
Yep.
Is this like 1 plus or minus 1?
Yeah. Plus or minus 1.
Plus or minus 2.
Plus or minus 2.
Plus or minus 4.
4. And that was it, right? Okay. So they ask you to then write the equation in factored, or the function in factored form. Okay, so the idea of this is that we have to somehow use these numbers and to factor it. Okay, so think about the factoring methods that you know. What are factoring methods that you know? Okay, so the grouping one comes to mind because there's 4 terms, right? So if we did potentially try the grouping method, would it work? Let's try it just out of funsies. So what would the greatest common factor be for this? You don't have to write this down, just pause for a second, just watch. X squared. Okay, and then what would be left over? X minus 1. What's the greatest common factor of the second one? Negative 2. Then what would be left over? Plus 4. So is this factorable? Not by that method. Okay, so grouping method isn't going to work. What else do we know? I'll give you a hint. It starts with an S. Yeah, synthetic division. Remember how synthetic division can help you factor? If you get a remainder of 0. It was on the last worksheet. So synthetic division helps you to factor. Okay, so what we can do is we can take these numbers, plug them into the box, do synthetic division, and if I get a remainder of 0, then I have one of the quantities. Okay, so let's say we pick one of them. Which one do you think might work? Anybody want to make an educated guess? 1. Well, I heard 1 first, but we'll go 2 next. Okay, pause, don't write this down, just watch for a second. Okay, so I'm going to do 1, okay, and then what are the numbers that are going to follow?
1, negative 1, negative 10, negative 8.
Okay, so we drop the 1, and 1 times 1 is 1. 0 plus 1 is 0 times 1, negative 10 plus 0, negative 10 times 1, and remainder is not 0. So, did negative 1 or positive 1 work? No. So that's a no. Okay, so we can keep going. We're going to have to try all of them until we find the right one.
Use like negative 1 too.
Yeah, so negative 1 could be a possible answer too. So there's negative 1, positive 1, negative 2, positive 2, negative 4, positive 4, negative 8, positive 8. Okay, so I'm so glad that you guys like sighed and you're like, oh my god, that's insane. Like, how many did you get for 2?
Too many.
A lot. A ton of them, right? Okay, so here's the thing. This little possible rational root thing was really nice 1,000 years ago when they didn't have technology. Okay, at least it narrowed it down a little bit for them. You know, like, well, that's only 8 possible values that might work instead of, you know, all of the numbers. So that was a little bit better. But nowadays we have technology. Okay, so I'm going to show you how to use technology to factor. Okay, so what you're going to do is we're going to start by graphing the function. Okay, you can use your graphing calculator or Desmos. Do you guys have a preference? Because I certainly do. Good, so me too. I love Desmos. Oh, by the way, in Desmos, not that you guys will ever really use this, but if you use Chrome on your laptops, your school laptops, they actually have, they allowed you to like put apps on there, and Desmos is one of them. It's pretty exciting. It's like one link, I don't know. You can always just put it as a favorite like I do, but anyway. Okay, what was the equation? I don't remember it off the top of my head. X cubed minus x squared minus 10x minus 8. Okay, so we have this, well, this is a John Travolta. Okay, and what do you think that we're looking for? Exactly. We are simply looking for the roots. Remember how it said on the thing? Actually, I think it didn't say roots. Actually, I take that back. Rational. No, it does say roots, doesn't it? Oh, no, it says 0. See? I knew it. So I said roots. Did anybody else notice that? I called these rational roots. And I think the worksheet, what does the worksheet say? It says roots, right? It says roots? Oh, it says zeros. Oh, okay, I guess I used roots. They use zeros. Did you know that a 0 is exactly the same as a root? They're identical, they have identical meaning. So now you know that a root is simply a place where the function crosses the x-axis. Okay, and the reason they replaced the word with roots at some point in time instead of a 0 is because, have you ever had a 0 of 0? Like, it crosses the x-axis at 0. So that's like, that sounds confusing, don't you think? Well, we have a 0 at 0. So it sounds a little bit better to say we have a root at 0. Maybe slightly less like zero-y. I don't know. Anyways, now you know that a root is a 0. So, what root do you see here? -2? Okay, now all we're going to do is we're going to use just one of them. Okay, so I'm still going to make you use synthetic division to prove it, but I'm going to let you narrow it down because the rational roots has so many. You still can use technology, but you still got to prove it algebraically. Okay, so which one of these do you want to pick? 4? Oh, I totally didn't say. Oh, okay, sorry, geez. -1. Okay, so -1. So we're going to take -1 and we're going to plug that into the box. Okay, and then we can prove that our Desmos is correct by having a remainder of 0. So we have 1, -1, -10, -8. Okay, we drop the 1 and we multiply. So what's 1 times -1? And -1 plus -1? -2, and -2 times -1? +2, -10 plus 2? -8 times -1? 8, and a remainder of? 0. I always like to put that the remainder in a box because it helps me remember that that's the remainder. So, just like that, we proved that -1 is in fact a 0. So, what is the polynomial that I have left right now? Okay, what was my exponent? X to the second, yeah. X to the second minus 2x minus 8. Okay, now I have to factor this further. We got a quadratic piece. Can I factor this? Okay, we could try easy method on this, right? Remember easy method? Are there two numbers that multiply to -8 and add to -2? I almost said the answer. What'd you say? Okay, which one's negative? -4, good. So this would factor into x minus 4, x plus 2. Okay, now what I have to do is I have to list the quantity that created my -1. Okay, what is the quantity that I used to create this? If I have a -1, x plus 1, very good. See how it all comes together? Okay, so the x plus 1 comes from the box number. So see how I have a negative 1? The divisor that I use to divide that, the quantity, is x plus 1. So if you were going to FOIL this out, you would get the exact same polynomial as our f of x function. It's pretty fancy, right? Okay. Should we do one more? No. Oh, plus 2. Oh my gosh. Good catch. Oof. I was just testing to see if you guys are paying attention. Good job. Okay, let's try number 6. Tell me what you got for your possible rational roots. Possible rational roots. What'd you get?
You did 6 or 2?
Number 2? Did I say 6?
Yeah.
Oh. Number 2. I don't know where I got a 6 from. I'm sorry. I don't know. I got nothing. Number 2.
Plus or minus 1.
Okay.
Plus or minus 60. Plus or minus 2. Plus or minus 30. Plus or minus 3. Plus or minus 20. Plus or minus 4. Plus or minus 15.
Oh my good lord.
Plus or minus 5. Plus or minus 12. Plus or minus 6. And plus or minus 10.
Holy cow. We could do synthetic division all day on that one. Okay, so this is definitely one we wouldn't want to like guess and check. That would take us forever. We'd need a big piece of paper for that. Thank goodness for technology. Okay, so the equation is x to the third. That's all I remember. Plus 2x squared minus 23x. Now Sarah might have some kind of special factoring rule that could figure this all out. Minus 60. She was kind of on to something that other day. She's in this class, right? Yeah. Okay, so what do you see? Give me a good spot.
5.
5. Okay. 5. Yeah.
So, do you want us to just...
Yes, I want you to put the proof. So I'm giving you like, here is at least a trick to narrow down those numbers, but I don't want you to just be like completely lazy and say, oh, the technology just does it all. I know the factors are x plus 4, x plus 3, and x minus 5. Done. Right? Okay, so we're at least going to show a little bit of proof behind it. Well, I want you to get the whole factor. So if you have an x to the third polynomial, then that means you should have, theoretically, 3 linear quantities. It should potentially cross the x-axis 3 times. It's possible that it only has 1, and the other one is like an imaginary, but we'll talk about that in the next lesson. So as of now, yeah, you have to come up with all 3 quantities. Doesn't work if you use -3? Okay, sure. Let's try -3. If you want to use 5, Tegan, that's fine. We should get to the same place. -23. Okay, so we drop the 1. Oh, yeah. Oh, okay. So -3, -1, 3, -20, 60, 0. Okay, good. So what's the quadratic piece that I have left over here? X squared minus x minus 20. Okay, so now we can factor that using easy method. What 2 numbers multiply to -20, add to -1? -5, positive 4. Good. Okay, and then what is the quantity from my box number? Don't forget that. X plus 3, good. Pretty easy? Shall I keep going? Are we good? Got it? Okay.